All right, here we're going to be talking about box and whisker plots. So just in general, box and whisker plot is a way of viewing statistics or just a list of numbers with a visual rather than having to look at the list of numbers and the individual numbers themselves. So there's a few key numbers in a box and whisker plot. First off, it actually just splits the data into 4 equal parts by using the extreme values, which are the smallest and the biggest, the quartile values, which it's in the name quartile. You kind of see the word quarter in there. It's splitting it into fourths. And then the median value, which is right in the middle. So we have some mathy ways of describing this, but it's really simple ideas. It's just the biggest, the smallest, the middle number, and then the quartiles are the middle of the bottom half and then the middle of the top half. So the lower extreme or the minimum is the smallest number. The upper extreme or the maximum is the biggest number. The median is the middle number. And then these quartiles, these are probably new words for you. Q1 is a way of shorthanding the lower quartile. Q3 is a shorthand for the upper quartile. And really all that's saying is that we're going to split the bottom half. So we have the lowest number, the middle number. We're going to split this bottom half in half again. It's the middle of the bottom half. Sorry, I got sloppy there. That says middle of the bottom half. And then this says the middle of the top half. All right, so we're splitting this into fourths. That's what quartile really is saying there. And that's what this visual is going to show. So we have the smallest one, or I'm going to call it the minimum here. That's this first dot here. We have the biggest number, that's the maximum, that's the dot all the way to the right. We have the middle number, that's called the median. This is right in the middle. It's not in the middle, you can see that it's not directly in between these two dots, but really it's saying that half of the data is on this side and half the data is on this side. And then after we make that split, we split it again. This is saying that for this range, for this part of the data, half is on this side, half is on that side. We call that Q1, or the lower quartile. Same thing is happening on the other side. Q3 splits this half in half. You can see that it doesn't look like it's in between. It's not directly in between this point and this point, but it's saying that half of this data is in here, and then the other half is in here. So like there would be 5 numbers in this list, 5 numbers in this list, 5 in there, 5 in there. It's being split into equal parts there. So that would be a total list of 20 numbers. 25% lay in each of those sections. 25% is in each quartile. This is 25% of the numbers. This is 25%. This is 25%. And this is another 25%, giving us the full 100%. All right, you might have heard the word range before. That's the difference between the maximum and the minimum. I'm just going to put that really simply. I'm going to say the biggest minus the smallest. It's basically how far is it from this dot to that dot. I'm going to clean this up. It's the distance between this one and this one. The interquartile range, you can see the word range there again, but now it's the interquartile range. That means between the quartiles. So now instead of talking about the biggest and the smallest, we're talking about the left side of the box and the right side of the box. That's Q3 minus Q1. How far is it from there to there? So the range is talking about how far is it from here to there. The interquartile range is just talking about for the box part of the box and whisker. How far is it from one end of the box to the other? The distribution and consistency is more of just a general idea. It's really talking about how clumped up everything is. This is not going to be a mathy definition at all. I'm just going to say the clumpiness of the data. Basically how big are each of these sections? That to there, how clumped up are each of these, or how wide are they? That describes the distribution of the numbers that we see in our list. All right, so we have this box and whisker plot that's showing number of eggs laid by lizards at the zoo. So this is showing that at least one lizard laid 2 eggs. Looks like one probably, or at least one laid 3. Some of them laid 6. Some of them laid 8. Some of them laid 10. So basically, these are just showing different data points. And then there's ones in between that are represented in here that we don't really see. But we at least see those 5 numbers represented on the box and whisker plot. So we're looking at what percent laid 3 or more. So 3 or more. Well, we know that each of these sections is 25%. That's 25, that's 25, that's 25, and that's 25. So 3 or more would be anyone in this section, or this section, which is 75% of the lizards in this data set. So let's say there was 20 lizards altogether that we're talking about. 75% of them laid 3 or more eggs. So it would be actually exactly the example that I said before, 5, 5, 5, and 5. So that would mean 15 out of the 20 laid 3 or more eggs. Here we're just looking for that as a percent, which is 75%. All right, now if there were a total of 56 lizards, how many of them laid 8 or more eggs? So 8 is there, or more. That means we're talking about the ones that are in this part of the data, which is 25%. So we're looking at 25% of 56, which you could type directly into Desmos as it's written there. You could write it as a proportion. You could change this into a decimal and multiply 25.25 times 56. Either way, that is 14 lizards. So that would mean that there's 14 here, 14 here, 14 there, and 14 there to give us the total of 56 lizards. All right, on the next page, we're actually going to create our own box and whisker plot. So the first thing we want to do, we kind of want to create a visual of the box and whisker just by creating a list from least to greatest. So right now, this is all jumbled up. I'm just going to carefully go through these and make sure I get them in order from least to greatest. 7 is my smallest. And then I have 2 9s. I think I have 2 10s. Just the 1 11. 2 13s, a 14. 2 17s. 3 18s. 2 20s, 2 21s, and a 24. Oh, sorry, 3 20s, 2 21s, and a 24. So these are describing how many wins Roger Clemens gets in each of his 20 seasons. All right, got all of them. So I want to try to make a box and whisker plot. So the first thing I'm going to do is just find the middle number. Actually, I guess I could label the lower and the upper extreme easiest. The lower extreme, upper extreme, that's the smallest and the biggest. That's 7 and 24. The middle, I'm just going to count my way to the middle. Well, I know there's 20 of them. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 from the left, and then 10 from the right. This is the middle. It's actually directly in between the 2 17s. So if those two numbers were different, we would actually find the average of those two. You'd count right in between those. But since they're the same number, the median is just 17. This is really the middle, or the median. Now the lower quartile is taking that bottom half and splitting that in half again. Well, I know that this is 10 numbers. It started out as 20. I cut it in half down to 10. So now I know 1, 2, 3, 4, 5. This is the middle of the bottom half. This is the lower quartile. Now it's directly in between the 10 and the 11, so we're going to call that 10.5. The exact same thing for the upper quartile. So lower quartile is splitting the bottom half in half. The upper quartile is splitting the top half in half. 1, 2, 3, 4, 5. That's the 5th number. So it's really directly in between these two 20s. So 20 is the upper quartile. All right, now I'm going to actually draw that. So I have a dot starting at 7. That's my lower extreme, with a whisker extending to 10.5. That's the start of the box. 17 is my middle of the box. 20 is the end of the box. I'm going to put dots there just to show that. I don't know if we really need that part, but. And then 24 is my last point. That's the second whisker. So I have a whisker, and then my box is created with my lower and upper extreme with the median cutting in the middle. All right, what's the range of the data? So that's the biggest minus smallest. That's 24 minus 7. I don't want you to get confused. This graph, the only numbers are going from 7 to 24, but that doesn't have to be the way it is. Like we could extend this graph and it could have the next few numbers on here. But we're not, the range is, it's not concerned about the graph. It's talking about these points. The biggest minus smallest, 24 minus 7, which is 17. The interquartile range, it's the same kind of thought. It's the range, the distance from here to there, but now we're talking about the interquartile range. So we're talking about, just for the box part, how far is it from Q1 to Q3? So that's 20 minus 10.5, or 9.5. We're just looking to fill in this sentence. Complete the sentence. 75% of the data points are blank or less. So that means we want to talk about 75% of the data. That's one whisker, one section of the box, and the second section of the box. So that means everything that's 20 or less is 75% of the number. So 20 or less. True or false? If you pitched one more season and got 25 wins, the median would increase. Actually, I'm going to go back to my list for that. So if I put the number 25 at the end of this list, let's imagine what happens to the middle. Instead of being in between these two 17s, it's going to jump just one spot over. And actually, it's going to be directly in between. It's going to be that 17, really. Because then there would be 10 numbers here, 10 numbers here. This would be the 11th coming from both directions. So the middle would still be 17. So actually, it wouldn't change. It would move, but it doesn't actually change value. So that's false. We're going to do one more quick one together, and then I'll let you try the rest on your own. So we have this box and whisker plot starting at 60. That's the lower extreme. We don't care about these numbers here. Like this is 57. That's not where our graph actually starts. It starts at 60. The upper extreme, it's not 75. It's going to be 72. Don't just worry about the graph. Really think about where those dots are. That's 72. The lower quartile, that's Q1. That's the beginning of the box. That looks like that's at 62. The median is the middle of the box. It looks like that's 66. And the end of the box, or Q3, is at 67. Right, the range of the data, that's 72 minus 60. Biggest minus the smallest, which is 12. That's saying how big is this graph, basically? How far does it go from beginning to end? Interquartile range is how far is the box going from beginning to end. So it's Q3 minus Q1, or in this case, 67 minus 62, which is 5. And you could just count that out. That is 1, 2, 3, 4, 5 spaces. That's what the interquartile range is talking about. How many spaces is the box? I hope this makes sense. Try your best to do those practice problems on your own. Come back to the video anytime you need it.